Welcome. On this video, we will discuss how to compute area by using integral. Okay, first we need a quick review. So recall that if we have a function which is above the x-axis, let's say something like this, and suppose we want to compute the area under the curve from x equal a to x equal b. Suppose this graph is the graph of the equation y equals f of x. Okay. Then we know that the area under the curve is given by, so area is integral from a to b f of x dx. Okay. Now let's move on into a more complex situation. So basically there are two type situation. Let me call it type 1. The type 1 situation is the following. Again, we have x-axis and y-axis, and then let's say we have something like this, and we have another like that. Okay. So on this type 1, for example, we want to find the area which is bounded by the red and the orange curves. So let's say we want to compute that area. Okay. The type 1 situation is the situation where the area that we are interested in is bounded above and below. So there is a definite top and bottom curve. Okay. For any point on this area, let me draw using another color. Let's say that one. If we draw a straight line, a vertical one, okay, then that line always touch the top curve and the bottom curve. Okay, so for any point on the area that we are interested in, it is always bounded above by the same curve and always bounded below also by the same curve. In this situation, the area is given by roughly top minus bottom dx. And then we need to adjust, let's say x is from a to b, so the area will be integral from a to b of top minus bottom dx. Okay. And the second situation, which I will call it type 2, is something like this. So again, we have a coordinate system, x coordinate and y coordinate, and suppose we have something like this, and then let's say something like that. Okay. On this type 2 situation, the area that we are interested in always bounded to the right by a certain curve and to the left by another curve. So this is right and then left. Okay. And then on this situation, the area is given by right minus left dy, where y runs from, on this case, let's say this is A, maybe use another letter, let's say C, and let's say that intersection point has y value equal to D. So in this situation, we integrate right minus left from C to D. Okay, let's look at the following example. Suppose we are interested in finding the area which is bounded by two graphs. The graph of y equals x squared and the graph of x equals y squared. Okay, so let's draw the two graphs first. So roughly y equals x squared is the following. Okay, and x equal y squared is this one. Oops. It's okay, so a little bit small area. Okay. All right. So this is the area that we are interested in. Okay. And let's draw this, and maybe let's continue up to that one, and over here we have this one. Okay. Now as we can see that this area is always bounded on the top by the green graph, and bounded below by the orange graph. So we can solve this problem by computing. So remember that area is integral of top minus bottom dx. Okay, so the orange one is the graph of y equals x squared, and the green one is the graph of x equals y squared. Okay. Now, since we integrate with respect to the x variable, then this top and bottom need to be written as a function of x. Okay, so the orange one is already written as a function of x, y as a function of x. Now we need to do the same for the green one. So we need to solve the green one for y. So the top part of the green one, if we solve for y, we have y equals square root of x. Okay? So it means now the area is equal to the integral from, not yet, at the moment, we're just interested in what is the top and what is the bottom. The top is y equals square root of x, and the bottom is y equals x squared dx. Okay, now we need to find the limit of the integration. Okay, to find the limit of the integration, since we integrate with respect to x, we need to find the x coordinates of the intersection points. So what are the intersection points here? The intersection points are that pink dots. Okay, the first pink dots is on the origin, which has x coordinate equals 0. So start from 0. And the second pink dot can be solved by setting x squared equals square root of x. Okay, if you solve that, solve x squared equals square root of x for x, you will find that x is equal to 1. Okay, so this is 1, and that's 0. So the area will be the integral from 0 to 1 of square root of x minus x squared dx. Okay, let's try to compute that. So area is integral from 0 to 1 square root of x. We can write square root of x as x to the 1/2 minus x squared dx. So we have integral of x to the 1/2 will be increase the exponent by 1, and then we divide by whatever number that appears on the exponent. So we need to divide by 3/2, which is the same thing as multiplying with 2/3. And then the integral of x squared is x cubed over 3. And then we evaluate at 1 and at 0. So we have plug in x equal 1, we have 2/3 minus 1/3, which is equal to 1/3. And when we plug in x equals 0, everywhere is 0. So the area is exactly 2/3 minus 1/3, which is 1/3. Now if we look at again our picture here, notice that we can also consider the orange one as the right graph. So we can consider this as the right graph, and then the green one as the left one. Okay, so in this situation we can also use the type 2 integration. So the area will be integral of right minus left dy. Okay, and by using similar argument, since we integrate with respect to the y variable, we want to express all functions as a function of y. So we already did that for x equals y squared. Then we need to do the same for y equals x squared. So we need to solve this for x. Solving for x, we have x equals, so this is the same as x equals square root of y. Okay, so now the integral become integral of right, which is x squared, I'm sorry, the right one is y squared, oh I'm sorry, the right one is the orange one, which is square root of y. And the left one is the green one, which is y squared dy. And then again, to determine the limit of the integration, we need to look at what are the y coordinates of the point of intersections. The y coordinate of the first pink point is 0, and the y coordinate of the second point is 1. Okay, and actually this expression is exactly the same as what we have computed before. The only difference is now we use y variables instead of x variable. So if we compute this, we will get the same answer, which is 1/3. Okay, so that's all for now. On the next video, we'll look at some problem where a specific approach need to be used. What I mean by specific approach is we can only use either the type 1 integration or the type 2 integration. So we need to make a choice. Okay, see you on the next video.